Okay, for today we're doing practice 2 and then review 2 and 3. So let's start off with practice 2 here. Okay, the half-life of a substance is defined as the period of time it takes for the amount of substance to decay by half. The sequence below shows the amount of a substance that will be left after a certain number of half-lives have elapsed. Describe the sequence here. So first off, on that, from 1 to 1/2 to 1/4 to 1/8, what is happening there? So we are dividing by 2, and therefore, since we're dividing by 2, the sequence, let's do it down here. This is a geometric sequence with a common ratio then of 1/2. So dividing by 2 is the same thing as multiplying by a half. And starts with 1 in the sequence, okay? Part B, calculate how much the substance will be left after 21 half-lives have elapsed. So for that, here, I am not going to write a recursive formula. The recursive formula, if we were, say, to try to use it, it would look like this, okay? We keep multiplying the previous term by half. But I'm going to go with the explicit formula. The explicit formula, as we were doing today, it's always the first term times the common ratio to the n minus 1, which in this case, the first term is 1, times the common ratio, which we found to be a half, to the n minus 1. So that's the explicit formula we would use for this entire problem. So when I want to calculate the 21 half-lives have elapsed, well, what that's actually talking about then is 21 half-lives. That's talking about the 22nd term. It's always plus 1 for the term. So if I'm at 21 half-lives, the plus 1, I'm actually focused on the 22nd term. So it's going to be 1/2 to the 22 minus 1, which is then 21. So now I go to my calculator. Oops, I'm kind of out of room there. 21 there. Now I'm going to do 1/2 to the 21st times 1. So we've done that before. When I do 1/2 to the 21st, I will go ahead and show you on my calculator here. So I bring that up. Give it a second. Okay. So 1 times parentheses for a fraction. We've done fractions before. I use the division key to the 1/2, or 1/2 to the now 21st. Your calculator is going to for sure return a decimal, a very, very small decimal. And I'm going to try to change that, change that back to a fraction if I can. Second math, sorry, not second math. Math fraction, and your calculator cannot handle that. This e to the -7 remains scientific notation times 10. It's a very small number. So I can't get that as a fraction. So from my calculator. So what I want to think about is, what is then 2 to the 21st? That number is going to be the denominator. 2097152. So what that tells me is I'm taking that 1 in the numerator, dividing by that number, and because it's such a large number, okay, there I can see those numbers the same. My calculator couldn't handle that. So I'm going to switch back then to my answer sheet and put then the fraction of that. It's going to be 1/2097,152. Okay, so that would be, in this case here, the amount of the substance will continue to get smaller and smaller as it decays. So as it continues to decay, it just keeps getting smaller and smaller and smaller. All right, then review 2 and 3. determine the function family for each equation here. So for this one, I see absolute value bars, so this is an absolute value. And then if I was to have you graph it, I think we'll go ahead and graph it in just a second. And letter B, I'm going to go ahead and I'll name it. This is the exponential function because it's to the x power right there. And then just to kind of have an idea of what this might look like, and remember how to graph on your calculator. Okay. So there we go. We go hit y equals, and it was -15. Absolute values, hit math, go over 1, ABS, and then was x minus 2. Outside of it, oops, go back up. Outside of it was then a something plus 430. Now this is not going to appear in my window because that plus 430. So to get that into window, if I hit zoom, okay, over here at zoom, and if I go and find number 0, zoom fit, that's going to kind of make it fit in my graph. So it goes up very, very high, and I can tell it's opening down, which makes sense. And this would be the absolute value graph I expect. For the other one, the exponential, I type that in, of 3 times -5 to the x power, that's where we get my x from, minus 17. Hit enter, and I hit graph, and I'm going to hit zoom, and I'm going to hit 0 because that's going to make it try to fit. Now it's going to look weird if I can even get something in there. It doesn't even look like I can try to get that in there. Yeah, so let's try zoom 6 standard. And I can't figure out there, it's not on there. So if I try zoom out, just to give you an idea of what that's going to look like. And there it is. It does not look pretty. I'm going to go back in, zoom in a little bit, see if I can kind of make it fit in there. And it's just not, because of how bad this function truly is that you're trying to have you graph. So anyway, I was just trying to give you an idea of what this thing would look like, and it just can't fit in there very nicely. Okay, no big deal. Just make sure you can identify what family we are. Okay, exponent.